All right, we're gonna get right back into it. Our next talk is Who Touched My GCP Project? Understanding the Principal Part in Cloud Audit Logs. Before we get started, I'd like to thank our sponsors, specifically Permiso. Permiso is a threat detection company that finds evil in cloud-based environments. Detection in identity, cloud, and SaaS environments has suffered too long from a one-size-fits-all SIEM approach. Modern environments require a purpose-built platform. Permiso uses human, non-human identity attribution to pair runtime and static data in cloud and SaaS into complete sessions where detections no longer have to rely on single events. Permiso's platform provides high fidelity, high resiliency, and maximum content for actionable detections that cut through the noise by analyzing human and non-human entitlements and behavior across authentication boundaries. Permiso gives companies a complete picture of every entity operating in and across their cloud environments and does not allow threat actors to hide in silos of overwhelming cloud activity data. Please welcome Gabriel.
Hello, can you hear me? Awesome. Hey everyone, and welcome to Who Touched My GCP Project, where today we're going to learn about the principal part in GCP audit logs. Every day in our environment, we could have GCP buckets being accessed, jobs being created, and unfortunately, cybersecurity incidents. Now, sadly, we could lose a lot of time and unfortunately money on false investigations when we can't understand who did what and how. So in order to resolve this and have lower time loss and possibly not any loss of money, it's critical for us to understand who touched our GCP project. So in order to do so, I'd like to go today over some GCP principles and logs we have, service accounts and service agents, where do they come into play, workload identities and workforce identities, what solution they provide, and we'll mention some cases that Google redacts caller identities and IP identities. I'm Gavriel Fried. I'm a senior security researcher at Mitiga. I have 10 years experience in cybersecurity. This is my first conference I'm talking in. And I'm a whiskey dude. So if anyone knows where I could get a drink, please let me know. So let's talk about GCP principle and logs we have. In GCP, we could categorize three main identity types. We have users, workload identities, and service accounts, where workforce identities, which I mentioned, are somehow a hybrid between the first two. Users are like human entities, like me and you, logging in with our emails to access our GCP resources. Workload identities provide external entities coming from things like external cloud providers and SaaS, access to our GCP resources. And service accounts are for service-to-service operations, meaning if we have some resource needing to access another, it will use this as its entity. In GCP, we have four kind of log categories which we could categorize. We have service logs, which are for standard error and output. We have agent logs, which are for agents which we could install on certain GCP resources and get information from that agent. We have network logs, which are for VPC flow logs, NAT gateways, and firewall rules. And what we'll focus on today, the cloud audit logs. The cloud audit logs tell us who did what and where, and they could be categorized into two sections, data access and admin activity. Where data access is stuff we're using to access certain data, and admin activity is about administrative operations. An example for this could be a creation of a bucket would be under admin activity, but accessing the data in the bucket would be under data access. So these are the four types of logs we could categorize in GCP. In our cloud audit logs, we have a section called authentication info. This tells us who did what and how, and it tells us the authentication method, a principal email, a service account key information, which we'll talk about in the service account section. It will tell us about third-party information and some delegation info for delegated impersonations, which we'll talk about later on. This structure looks something like this. We could see in this structure, we have another structure called service account delegation info. This is for impersonation chain of service account and service agents, which we'll talk about later down the line. But this section, just to keep in mind, looks something like this. So something small we can remember, we have four types of logs, three main identities, and two interesting structures. So once we talked about that, let's shift to the service account and service agents. What are service accounts? Service accounts provide an identity for a resource to access another resource. And an example usage for this, to get this into our head, is kind of like having an application on a VM which needs to access our GCP bucket. So this will be done using a service account. We could identify these by the gserviceaccount.com prefix. Wait. Okay. There are three types of service accounts. Service accounts, just to a head start, when they authenticate, they need credentials, which are usually a JSON or P12 key. So we have three main categories. We have user, which are custom made, built-in service accounts, and Google managed service accounts. The custom ones that a user could create, or we could give them certain types of roles, specific scopes, and we manage their keys for access. The Google built-in service accounts are kind of Google's way to give us a head start on certain services. For example, if we have the Google Compute Engine and we enable this API, Google will create the service account and its keys to get us started. And the Google managed are technically what we will later refer to as the service agents, but these are for internal operations happening in our Google environment, and their keys are completely managed by Google. So, how can we access these service accounts? Well, we have two types of methods of accessing them, through activation and through impersonation. When we activate a service account, we're essentially logging in as the service account. We need to provide a key, and then we're essentially, if our gcloud command is activating it, we're kind of logged in as the service account. This could be done using this command. Now this is what I'd call a bad impersonation. But now let's talk about service account impersonations. A service account impersonation allows a service account to act on our behalf to access a certain resource. As we can see here, a user might need to impersonate a service account to access a resource this service account has. This will allow us to have temporary credentials to the service account to access the resource. Now, we could have legitimate cases for impersonation, some malicious cases for impersonation, and two types of impersonations. A legitimate case could be when we want to delegate access because we don't want our users to always have access to everything. We might need this to automate tasks on certain software we have to impersonate service accounts for resources, and we might want to give external entities access to our resources, which we'll talk about later on, to get resources from outside into our GCP environment. A malicious actor might use this to either exfiltrate data because a service account might have the right permissions, escalate their privileges because it might have higher privileges, and certain types of attacks abusing their behavior, and to possibly cover their tracks. Why? Because we might say, okay, a service account is operating in these logs, it's all good. Now, there are two forms of impersonation. One is the activation we mentioned previously, and one is a specific invocation. What happens when we have a specific invocation? We're essentially getting temporary credentials to act on one certain command to allow this service account to act on our behalf. What we need for this is a role called service account token creator. Why? Because what happens when we impersonate, we're generating an access token, which allows us to have temporary credentials for the service account to allow it to operate on our behalf. So, we understood so far that in service accounts we have activation and impersonation. Let's see how this looks in our audit logs. When we're activating a service account, as we mentioned, we're essentially logging in as the service account. So the authentication info section will tell us our principal email was the actual service account operating, because now our session is as the service account. But when we impersonate a service account, we will see our user, which is instigating this specific invocation impersonation, doing a generate access token operation to get the token for the service account. And in our resource section of the logs, we will see our service account as what we're trying to impersonate. So this is how these look in the logs. But we mentioned before something called delegation chains. So what is that? A service account delegation chain means that sometimes we might need to have several impersonations going out because a service account doesn't have the sufficient permissions to do something. It needs another service account, or you might want to move around some type of permissions. So a user might impersonate service account A, which needs to impersonate service account B to access our resources. For this, we'll need the getAccessToken and, again, the service account token creator. Now let's see how this looks in the logs. When we're starting a delegation chain, we will see the invoker, or in this case, our username, doing a getAccessToken for the full list of service account we need to impersonate, because each entity in this chain will now also need to generate an access token for the next one in the chain. But when we see, But when we see the operations happening with the delegation chain, what we'll actually see is, is the last service account in our delegation chain, which we needed to actually access our resources, but in the identity delegation info, we'll see the reverse order of who actually initiated this operation, which is critical because if we see an operation happen in an incident, we could trace this back to the actual original invoker. But sometimes, because we mentioned each one needs to generate an access token, we're not sure if this started as a specific invocation or a delegation chain. Well, for this I have a tip. You could look at the permission scope. When we see an event for generating a token, if we have a single invocation, our permission will be the getAccessToken, and our identity will only involve one service account. But when we're starting a delegation, our permission scope will involve implicit delegation, and in our resources, we will see the information, in our metadata, we will see the information of all the identities we want to impersonate. So far we understood that service accounts have these operations, impersonations, and delegation chains. Now, I'd like to talk about the curious case of the Google Compute Engine default service account. We mentioned that default service accounts are kind of like a hit start to our operations, right? So one of these is the Google Compute Engine service. Now, Google allows us to attach our own custom service account to a VM if we want certain operations to happen, and this will be the entity acting for this virtual machine, kind of like managed identities, if anyone knows how they are in Azure. So what I'd expect the behavior to be is that we see an operation from this VM happening by this attached service account. But what we noticed is that each operation, even with an attached service account, actually happens by a delegation from the default Compute Engine service account. So seeing this is not like something unusual, but it's just unusual as a behavior and something cool to notice. So now let's talk about service agents. Service agents act on behalf of like certain type of services in Google. They're usually attached to them, like the Google Sync for logging operation. These things are logged for transparency, and their keys that we mentioned before, like we use for activation, are completely managed by Google. And therefore, you cannot impersonate service agents. Here are some examples of service agents, but I'd highly recommend looking at Google's documentation for a full list. Let's see how service agents look in our logs. Here again, we see our Google Compute Engine default service account, which we remember, and this was actually an operation invoked by our service agent, as we see over here. So this kind of sums up our service agents and service account section. We learn about impersonation, delegation chains, weird cases with the GCE, and service agents. Now let's talk about workload identities and workforce identities. Workload identities provide external cloud providers or SaaS applications an identity to access our GCP resources. Why would we need the solution? Because we mentioned that sometimes we might want to get a service account through keys or log into our GCP environment, and having keys around is a security risk, and we also don't want the complexity of managing external entities. So what solution do we have? The solution here is that we have keyless authentication because we have an IDP trust to our GCP environment. Now let's see how this works. Our workload entity will first start by authenticating with its external IDP. It will then get its credentials back from the IDP and send these credentials to the Google STS service, which is the security token service in Google, which verifies the authentication with the IDP. Once this entity is verified, the STS will return a GCP access token. Now, we remember what we could do with these tokens. We can impersonate a service account, which gives us access to the GCP resource. So this is how this works. Now let's see how we could identify these things in our logs. Let's talk about the STS token exchange in our logs. Something really cool here is we have an external workload identity coming from AWS, where we could see the account ID, the role it assumed, and the session ID, which means, like, for forensic investigations, this is gold because we could trace something all the way back to a specific session ID in AWS. We will see here Google giving us a mapped identity for this external entity. This is how this identity will now be represented in our logs, and the operation will be the token exchange for Google. Here's another example, but why am I showing you first the mapped identity? Because what we see here is that when it comes from Azure, we get the object ID, which we could trace back to Azure if we had an incident, starting from there. So once we have our token, our STS token, we want to impersonate a service account. So what we see here is that we're starting with our mapped entity, which we saw in the token exchange, doing a generate access token for a resource, which is the service account, which we need to impersonate to access our logs. This, before what we saw, was an AWS, which we know what we could trace back. But now, let's see what happened once we impersonated. Once we're impersonated, our AWS, we will see a service account operating, because we already impersonated, and our principal subject in the service account delegation info will be our external entity. Now GitHub has something called GitHub Actions, which are for CI/CD operations, which kind of like on pull requests could allow us to like spawn VMs to check our deployment. So what we see here is a service account operating, but our principal subject is actually a GitHub, and we get it straight from the repository, the path all the way up to the PR of what spawned or did actions in our GCP environment, which is really cool because if someone had access to our GitHub, we can actually trace this all the way back to GCP. Let's talk a little bit about Workforce Identity Federation. This is essentially kind of like the same solution, but for users, but without impersonation. A user authenticates to the IDP and then has direct access to our GCP environment. The solution here is that also we don't have to sync users. If anyone knows Entra ID and on-prem, you have to sync your users and you have to manage them. We can manage them using Workforce Identity Pools. This is how Google describes the operation. Fairly similar, but no impersonation, where we authenticate to the IDP, get a token verified, and access our GCP resources. The way this will look in our logs is fairly similar. The way our user authenticated to its IDP, in this case a user and an email. Short pop quiz, let's see if anyone got anything so far. A few seconds. Let's see if anyone can understand what happened here. So, what happened here is something I stumbled upon myself, was that I saw a service account operating, but I saw this principal subject, that SVC ID GUG, which I didn't understand what it was. This is actually the Google Kubernetes Engine default service account attached with an IAM policy to a service account. So this is a hint if we're investigating anything from Google Kubernetes Engine and we see the SVC GUG, we could even trace things back to the namespace and the Kubernetes service account that we had inside our environment, which is really cool for investigations. Now let's have a short brief about cases where Google redacts caller IPs or caller identities. In BigQuery, sometimes we have cross-project access with different domains, so Google might redact this for privacy, GDPR, and all those fun reasons. Caller email in virtual networks, they might call it Google internal, and if we have VMs without external IPs, they might just call it like Google internal or remove it. I highly recommend looking at Google's documentation for all the use cases we have. So, in order to summarize this up, We now understand the different types of identities, how they look in our logs, and how we could investigate these incidents. I would like you tomorrow to check your GCP logs, see if you could understand what happened there. In a week from now, if you have an incident, can you tie it back? And in a month, write detections based on your environment, impersonation patterns, and what you know. And if there's one thing I could have you all take away from this, is that once we understand the principles, we could easily investigate and understand who touched our GCP project. Thank you very much. I was Gavriel Fried. Thank you so much.
Were all the logs that you showed in the default audit logs that are enabled by default, or did you have to turn on data access logging for any of those?
Yeah, so some of them were from data access and some were from the audit logs.
Is that in that link? I was curious.
Oh, this link is just my LinkedIn if anyone wants. Feel free. Yeah.
Yeah, one other question. Great talk, by the way. One of the things that we've noticed when we see ransomware in GCP is that their mechanism for persistence is to create a service account but try to make it look like a service agent with nomenclature. Do you have any tips on like identifying that inside the delegation chain or anything like that?
So a few things you could have is, first of all, Google has an immense list of all the service agents. There are specific resources which have designated service agents. Another cool thing, which I also noticed myself, is that each listed service agent, which they might try to fake, has a list of specific roles it should have. So if you see it acting something that it shouldn't be doing, that's a really cool point, because for some reason, Google allows you to add additional roles, but they're like, don't do it, you might break stuff. But yeah, so if you'd see it operating.
Hi. So I actually work at Google, and it's a good talk. I actually didn't know this much about role delegation and service accounts because I use mostly Borg. But I have a service called Access Transparency, which I don't know if you've used, which tells you when Googlers access your data. Have you had experience with that? And I thought I was getting your thoughts.
So I'm aware of the Access Transparency log, which Google kind of allows you to see what they're doing, but I haven't seen the logs myself to integrate, because what I know from main detection and investigation, people go to the cloud audit, but that's something I definitely should look into.
Hey, Gabriel. Cheers.